Hi there, in the last video I explained how to work out the equation of the plane containing or which is formed by a line and which is parallel to another line. Okay, so let's go back quickly. So to work out n, the normal vector, in that video I explained we need to take the cross product of the direction vectors m1 and m2 from the lines, and to work out capital P the formula was a dot n. But A is a fixed point on your plane. A, we take that to be A1 because this line is contained on the plane, and this is the position vector of a fixed point on your line which is also on your plane. So take A to be, so when choosing A, always look at the line contained or the line which is formed in that particular question that you're looking at. Okay, so let's take an example. So example number 1. So let me underline this. So the question being, let's find the equation of a plane in the form r dot n is equal to capital P, so in scalar product form, which contains the line. So the equation of this line is r equals I minus 6k plus lambda into minus I plus 2j plus 5k, and which is parallel, so it's parallel, okay, in this case to the line, so 2r is equal to 2i minus k, okay, plus mu, open a bracket, 2i minus 3j plus k. So let's go over the methods as explained in the previous video. So going back, so in order to work out the normal vector n, the normal vector n can be found by taking a cross product of the direction vectors of the lines. Okay, so coming to our current example here, so here are the direction vectors of the lines circulated in red. So I'll take this as m1, this vector here as m2. So my step number 1, so here is step number 1. Step number 1 is to calculate the normal vector n, that is m1 cross m2. So when working out a cross product, remember that is the determinant calculation. So it's going to be the determinant of a 3x3 matrix. So the first row we write down the unit vectors I, j and k as always. Okay. In the second row of that determinant, these are the coefficients of I, j, k in m1. So in m1 the coefficients are minus 1, 2 and 5. So minus 1, 2 and 5. And in the last row, the third row, these are the coefficients of I, j, k in m2, which are 2, minus 3 and 1. So 2, minus 3 and 1. Okay, so as always I like to expand my determinant using the first row, and the signs associated for the first row are plus, minus and plus for 3x3. Okay, so when we expand, we're going to have plus I multiplied by the determinant of a 2x2 matrix, remember. So if we cross out the row and column associated with that first element I, the elements in that determinant are 2, 5, minus 3, 1. Okay, minus the j, so minus j multiplied by, cross out the row and column associated with j, and the elements of that determinant are minus 1, 5, 2 and 1. Okay? And finally plus k multiplied by the 2 by 2 determinant, cross out the row and column associated with k, and the elements of that determinant are minus 1, 2, 2, minus 3. Okay? So if we simplify, so we're going to have I multiplied by, remember when calculating a 2 by 2 determinant, it's multiply the elements along the red diagonal, then subtract, then multiply the elements along the opposing green diagonal. So 2 times 1 is 2, then we subtract, then multiply the elements along the green diagonal. 5 into minus 3 is minus 15, with this minus plus 15. Okay, minus the j, same operation here, multiply the elements along this red leading diagonal. So minus 1 into 1 is minus 1, then subtract, then multiply the elements along the lateral green diagonal. So 5 into 2, 10. Finally plus k, open a bracket, multiply the elements along the leading diagonal, minus 1 times minus 3 plus 3, minus, then multiply the elements along the lateral diagonal, 2 times 2, 4. Okay, so if we simplify further, 15 plus 2 is 17, so 17i, minus 1 minus 10 is minus 11, minus 11 into minus j is plus 11j, and 3 minus 4 is minus 1 times k minus k. Okay, so that completes step number 1. Step number 1 is the normal vector. And step number 2 is to calculate capital P. So to work out the scalar capital P, it's a dot n. Okay, so capital P is a dot n. So remember, be careful when choosing a. A comes from the vector which is contained on your plane. Okay, so the vector which is contained on the plane is this one, and a, so let me use a green pen, is going to be this vector. Okay, as this is the fixed point on your line, and that fixed point on the line is also contained on the plane, as this line is contained on the plane. Okay, so let me make a note. A is I minus 6k. So capital P is A is I minus 6k, dotted with n. So n, normal vector, answer of step 1, 17i, plus 11j minus k. So if we multiply the I coefficients, 1 times 17 is 17. Multiplying the j coefficients, no j coefficient, so 0 times 11 is 0. Plus, multiplying the k coefficients, minus 6 times minus 1 plus 6. Okay, so 17 plus 6 is 23. So that is the value of the scalar P. Okay, so that takes us to the last step. So let me call this step number 3. So to work out the equation of the plane, the formula being r dot n is equal to capital P. Okay, so we know the normal vector, so it's r dot normal vector, answer of step 1, 17i plus 11j minus k. So 17i plus 11j minus k, that is equal to capital P, answer of step 2, 23. Okay, so that is equal to 23, which completes this example. Okay, so here are the steps in order to work out the equation of the plane which is containing, or which is formed by, one of the lines and which is parallel to the other. Okay, a couple of things to note. To work out the normal vector n, you take the cross product of the two direction vectors of the lines, and most importantly, in order to work out capital P, it's a dot n, but a comes from the fixed point, okay, on the line which is contained on your plane. So a in this case is I minus 6k. So don't accidentally take this point here, because this line is parallel to your plane. So this line is not contained, or it's not forming your plane. Okay. So that ends this video also. So I hope you found this video helpful. Do related questions, and I hope to see you in the next video. Thank you.